need to expose a product catalog to your AI without writing complex API documentation. You'll see how to create a searchable product database tool in just 12 lines of code, complete with optional category filtering and version metadata. The pattern uses FastMCP's Decorator system to automatically generate all the schema information your AI needs to call it correctly.
At MCP, tool. Name equals find products, hash custom tool name for the LLM. Description equals search the product catalog with optional category filtering, hash custom description. Tags equals catalog, search, hash optional tags for organization filtering. Meta version 1.2 author, product team, hash custom metadata. Def search products implementation, query, SDR category, SDR none equals none list dict. Internal function description, ignored if description is provided above. Hash implementation, printf searching for query, in category category. Return id, to's name, another product.
This demonstrates the Decorator-based tool registration pattern, where Python functions are transformed into AI-callable endpoints through declarative metadata. The @MCP tool decorator acts as a bridge between your implementation code and the MCP protocol, converting native Python functions into typed, discoverable tools without modifying their core logic. What makes this distinctive is the complete separation of interface definition from business logic, achieved purely through type annotations and decorator arguments. The pattern works by leveraging Python's introspection capabilities to extract function signatures, type hints, and docstrings at runtime. FastMCP automatically generates tool schemas, handles parameter validation, and manages the RPC transport layer, while your functions remain simple, focused units of work. This creates a clean contract where the decorator defines the interface requirements, but your implementation stays framework agnostic. You write normal Python that just happens to be remotely callable. This approach solves the classic problem of RPC boilerplate while maintaining strong typing and discoverability. It's particularly valuable for AI integrations, where you need to expose backend capabilities without writing custom API layers. The trade-off is some initial framework coupling through decorators, but the benefit is eliminating manual schema definitions, validation code, and transport handling, letting you focus on the actual functionality rather than the plumbing. Let's break it down line by line.
At MCP, tool. Name equals find products, hash custom tool name for the LLM.
The @MCP tool decorator registers this function as an AI callable tool. The name parameter defines how the AI references it, decoupling the implementation name from the exposed interface. This enables versioning and renaming without breaking existing AI workflows.
Description equals search the product catalog with optional category filtering, hash custom description.
This description defines the tool's purpose for AI models, appearing in tool selection interfaces. Without it, the AI would only see the function name, making informed tool selection impossible. Always include a clear, action-oriented description for AI callable tools.
Tags equals catalog, search, hash optional tags for organization filtering.
The tags parameter categorizes tools for discovery and filtering. AI models and tool registries use these metadata tags to quickly find relevant tools, like filtering a catalog by search capabilities. This follows the common metadata tagging pattern for API organization.
Meta version 1.2 author, product team, hash custom metadata.
The meta parameter attaches custom metadata to the tool, enabling version tracking and ownership identification. This becomes critical when managing multiple tool versions or debugging production issues, as it preserves context about who created the tool and which version is deployed. Standard practice is to include version, author, and any other relevant operational tags. This closing parenthesis terminates the @MCP tool decorator declaration, finalizing the tool's metadata configuration. Without it, Python would expect additional decorator arguments, causing a syntax error. Always verify decorator closure when tools fail to register.
Def search products implementation, query, SDR category, SDR none equals none list dict.
This defines the actual implementation function that powers the AI tool. The type hints specify a required query, string, and an optional category parameter, while the return annotation guarantees a list of product dictionaries, enforcing the contract declared in the @MCP tool decorator.
Internal function description, ignored if description is provided above.
This docstring is a Python function description that gets ignored when the @MCP tool decorator provides its own description. It serves as internal documentation for developers, while the decorator's description parameter defines what AI models see. This separation keeps implementation details clean while exposing only relevant information to AI tools.
Hash implementation. Printf searching for query in category.
This placeholder implementation demonstrates the tool's execution flow. The print statement simulates logging the search parameters, showing how the function receives and processes the query and optional category inputs. In production, this would be replaced with actual catalog search logic against a database or API.
Return id, to's name, another product.
This returns a mock product list matching the expected schema, demonstrating the tool's output format. The hard-coded response simulates a successful search while maintaining type consistency with the declared return type, listdict. In production, this would be replaced with actual database query results. FastMCP tool decorator pattern. The @MCP tool decorator bridges Python functions and AI clients by generating schemas, where metadata overrides function signatures to create domain-specific interfaces. The description parameter completely replaces the docstring for LLM exposure, making internal documentation invisible to clients. A well-tagged tool becomes discoverable across multiple contexts without code changes.
The decorator that names the tool becomes nameless in the registry.